Okay, welcome back to the second part of this chapter on combinational logic circuits. So in the previous chapter, what I did was that I gave you the circuit. Okay, I gave you the circuit layout and I told you to come up with the SOP expression. Okay, and how you do that is, of course, you need to draw the truth table. Okay, so in this second part, what I'm going to do is I'm going to give you the SOP expression, and I want you to use this SOP expression to draw out the circuit using some logic gates. All right, so this is the part that we are going to do in this video. Okay, so well, the whole idea is that we want to take it step by step. Yeah. So the first thing is I want to find out how many inputs there are. So is this an example? Yeah, let's look at this example. This is a word example 12.3. So I know I've got A, B, C. So I know I've got three inputs here. Okay, I've got three inputs here. Yeah, so I need three inputs. The next thing is I want to kind of divide this into the ends here. Okay, so it's A complement and C, or B, or A and B complement and C. Okay, so the whole idea is I want to break it up into the ors. All right, so that's the way that I do it. I know some people might do it other way. I want to break it up into the ors. Okay, so I want to do this in 3 steps like so. So the first step is they are tackling the A complement and C. So A complement and C look something like this. I have A. To make it into a complement, I have to put a NOT gate, therefore it becomes the opposite. And C, so I need to have an AND gate, so C signal goes here. So this becomes A complement and C. What about A, B complement and C? So this is a 3-input AND gate. Same thing, A is quite straightforward, goes into A, C is quite straightforward, goes into C, but B, I need a complement. So I need to put a NOT gate in between the B signal and the input of the AND gate here. Okay, so it becomes A, B complement, and C. Okay, so then B, of course, we don't need to do anything, it's just a straight up B in. So this or B or this will give me the output X. So I need to have this fella here. Okay, this comes from this fella. This comes from this fella, and B is just straight in. So all these three, 1, 2, or B, go into a 3-input OR gate to give me the output expression. Okay, all right, so I kind of hope that you get it. If you don't, let's take a look at this review question here. Pause the video here. I want you to just try this on your own first. Okay, just pause the video and I will work it out after you have worked it out. So pause the video and click play when you are ready. Okay. Okay, hope you tried this on your own. So right now, this is the SOP expression. We are going to come up with the circuit. All right. So let's choose a different colored pen. Let's use green. So same thing. I'm going to divide it into the something or something. Okay. So I know at the end of the day, I need a OR gate. Okay. So let's come up with this fella first. It's A complement and B complement. So I know there is a AND. There are 2 inputs, so let's have input A and let's have input B here. Okay, so the first AND, let's draw the first AND somewhere here. Let's plan it, but before that I know I need a NOT gate. Okay, so I know I need a NOT gate here. So let's draw a NOT gate, and the A goes here, so this becomes A NOT. I also need a B NOT. So let's draw another NOT gate here. And this time, this goes to B. So this becomes my B naught. And these two will be a N. Okay, the dot is an N. So let's draw an N gate here, like this. Now, you notice that I am making sure all my lines are either horizontal or vertical lines. Yeah. So this is my A complement and B complement. Okay, so I've settled this. Now let's go on to A and B. So I just want A and B. Yeah. So very simple. This one goes, and I'm going to need, so don't forget the dot. I'm going to need A coming here, going here. Okay, so this is my second intermediate output, A and B. So this is my A and B. And this two is odd together. The middle cross is odd together. So I need a OR gate here, like so. And these two inputs come in here. Okay, and finally, my output X is A complement and B complement, or A and B. Okay, so this is how you work it out. Take it step by step, part by part. Always work out the individual ends first, and finally you OR everything together. The OR output can be a 2-input, can be a 3-input. I don't know whether they'll give you 4 inputs, but if they do, yes, there are 4-input OR gates as well. So you can very well work those out yourself. Now I want you to try this one. This one is a bit tricky. I want you to try it yourself. If you're not sure how to do it, you can look for me in class to kind of find out how it looks like eventually. Okay. But so actually it's doable. But do you think we can simplify this somewhat? Well, if I'm asking this question, the answer is actually yes, which would lead me to the next part of this video series, simplifying circuits, simplifying these circuits by simplifying the SOP expression. Okay, so that's the next part. Go and practice this question here first, though. Okay, go and practice this before watching the next part. Okay, so see you in a bit.